going to study the motion of center of mass today. So we know one thing regarding motion of center of mass. So we know the position of center of mass of the discretely distributed mass in the system of particles. So if R represents the position vector of center of mass of discretely distributed masses, then this is represented by sigma Ri Mi upon sigma Mi. This is the position vector of center of mass, right? And this is the position vector. Ri is the position vector of ith mass, right? And the discretely distributed masses is the sigma of Mi. So this can further be written as R, R center of mass. This is the vector. We can write R1 M1 plus R2 M2 plus, if there are n particles, so Rn Mn upon, this is the total mass of the system of particles. In a system of particles, there are n number of masses and total mass is m. Now, this can further be written as m r center of mass, that is equal to r1 m1 plus r2 m2 plus like this, that is rn mn, that is nth mass. Now, if we differentiate this with respect to time, we will write therefore m dr upon dt, of course it is center of mass, that is equal to m1 dr1 upon dt, it is vector, plus m2 dr2 upon dt plus like this, that is mn drn upon dt. So now we know one thing, that this differentiation of this position vector with respect to time gives the velocity, that is velocity of center of mass, that is m1 velocity of first particle, right? It is a vector, plus m2, that is the velocity of second particle, plus like this, plus mn velocity of nth particle. So what do we observe from this relation? That is m into this velocity of center of mass. This is the momentum of the center of mass. Momentum of the center of mass is the sum of momenta of all these particles in the system of particles. If it is differentiated further, see, if it is being differentiated once again, so what we will get? Total mass, mass of the system of particles, that is dV center of mass upon dt, differentiation with respect to time, that is we will get m dV1 upon dt plus m2 dV2 upon dt. Likewise, if there are n particles, that is the Vn upon dt. This is what? This can be written as d mVcm upon dt is equal to d mV1 upon dt plus, it is of course m1, derivative of m2 v2 upon dt plus like this, differentiation of n and vn upon dt. What does it mean? That is the momentum, right? Therefore, this is dp center of mass upon dt. Momentum is, linear momentum is represented by p. P is mVcm, that is the momentum of the center of mass, This is the momentum of the first particle. So we will write P1 dP1 upon dt plus dP2 upon dt plus like this dPn upon dt. Rate of change of momentum is what? This is the net force acting on the object. This is the net force acting on this of first particle, second particle and nth particle, and this is the total rate of change of momentum of center of mass. So we can write dP center of mass upon dt is equal to, what is this? Net force acting on the first particle. So if net force acting on first particle is denoted by F1, right, plus F2 plus like this plus Fn. So these are the net force acting on these individual particles of system of particles. So one thing we know, the force acting on these particles are external force as well as internal forces. So F1 means force acting on the first particle, total force, external as well as internal forces. So if we denote F1, of course these are vectors, these are not magnitudes, they are vector addition of these forces. F1 is equal to F external on 1 plus F internal on 1. F1 means on the first particle total external force plus total internal force. Likewise, all these forces having total internal as well as total external forces. So F2 if we write, we will write F external 2 on second particle, that is F internal 2. Likewise for all these forces. So first we will understand that all the internal forces acting on these particles will always be 0. Only external forces will be left in totality. The net external force will be the total force acting on this system of particles. So we can consider how the internal forces acting on the object will be 0 in this case. For the sake of that, what I will do, I will consider 3 particle system. For example, there are n number of particles may be there, but for understanding we will consider only 3 particles. See, 3 particles are there, 1, 2 and 3. Suppose it is M1, this is M2, this is M3, and this is making a system of particles, right? So what are the internal forces? Internal forces are the forces of attraction between these number of particles. This intermolecular force of attraction will be the internal forces. So force of attraction due to this mass will be this on this, and on this force will be acting over here. So suppose we consider that F1, so this will also be F1. Here this is F2, this is also F2. Here again this is F3 and this will be F3, because these forces are equal and opposite. So if we consider net internal forces acting on these particles of system of particles, what will be observed? So net internal forces, total forces acting on this particle is F1 internal, right? F1 internal is equal to what? Forces acting on this mass, that is F1. This is F1 plus F2. F1 plus F2, these are the forces acting on this M1 mass, and we have denoted F internal 1. Likewise F internal 2. Second mass is this, that is F1 and F3. F1 and plus F3, right? Now see, this direction I have chosen as positive for F1. this is direction is chosen as positive, so this direction will be, if you look at the vector form, if you are taking vector form of these forces, then this will be negative F1, this is chosen as positive, so this will be negative F2, right? And this is chosen as positive, then this will be negative F3. So we can write F1, this is F1, this is F2, this is F3, and this is F1. So this will be on M2, this is minus F1. So this is minus F1 over here. Likewise, F internal 3. On the third particle, if we look at what are the internal forces acting on the third particle, on this. So we will get minus F2, that is minus F2 minus plus minus F3. These two forces are acting on this. And if you add all these forces, internal forces, what will you get? So that's F internal 1 plus F internal 2 plus F internal 3. So if you add all these, we will get F1 plus F2 minus F1 plus F3 minus F2 minus F3. If you add this, we will get F1 will go with this, F2 will go with this, F3 will go with this, that is equal to 0. So sum of all the net forces acting on the individual particle, that is the internal forces, sum will always be 0. So here, if you look at F1, F2, F3, Fn and F1, F2, all these are external plus internal. So we can write that is F1 external force, or you can write like this, F external 1 plus F internal 1. Similarly, F external 2 plus F internal 2, right? And likewise, if you add all these, so F external n, this is F internal n. So all the internal forces, this plus this plus this, all sum of all these forces will become 0. So we will be left that with F external 1 plus F external 2 plus like this, so F external n. So rate of change of momentum of center of mass will be sum of all the external forces acting. So suppose external force is this, F external, right? So this external force will be the forces acting on this and this. So all these forces, external forces, will be distributed on all these masses. So sum of this will be nothing but F external. So net F external force is equal to rate of change of momentum of center of mass, right? That is equal to F external. So this is a very important relation. If the external force acting on the system of particles is 0, then what happens? If the external force acting on the system of particles is 0, that is F external, that is equal to 0. Therefore, dp center of mass upon dt is equal to 0, and this implies p center of mass is equal to constant. Means momentum of the center of mass of the system of particles will be constant when external force acting on this will be 0. In this case, what happens, you see, due to these forces, internal forces, and previously also I had told that due to this, individual particles will be having motion. if external forces are not acting, even though sum of the internal forces is equal to 0, but due to these internal forces, bodies will be in motion inside the system, right? But center of mass, momentum of that will be constant. Even though particles will be having different momenta, individual particles will be having different momenta, but vector sum of all these momentum will be such that momentum of the center of mass will be constant when there is no external forces acting. So children, I will be stopping over here. We will meet again on the next video. Till then, all the best. Take care of you.